absolute function equations. Write an absolute function equation which has one solution, then two solutions, more than two solutions, and no solutions. So we need to give possible equations for these. So let's try to sketch some absolute functions and then figure out a solution. So let us say this is our coordinate axis and we have an absolute function which is, let us say, like this. And if this point is plus 1 and we need to write an equation for this absolute function with one solution, what can we give as our equation? Well, we could say absolute value of x, we have moved one unit to the right, that means minus 1 is equal to 0. So the only solution is x equals to 1. Do you see that? So the solution will be x equals to 1. So that is how we can write down absolute function which has one solution. Now let's look into two solution possibilities, right? So for two solutions possibility, what we can do is we can, okay, let's consider the same function. So this time what we will do is we'll draw a similar function and let me change it a bit. So let me draw it this time on that side, that is move one unit to the left. Now if we are looking for two solutions, that means we are looking for a value which will be kind of like this, so crossing at two places. So that is what we are looking for. So we can write down a function which is, let us say, absolute x. Since we moved one unit to left, it will be x plus 1, right, is equal to not 0 this time but something else, correct? It could be 2, for example, right? Now 2 means this value could be plus 2 or minus 2. So we get two solutions, which is x equals to, we can write x equals to 1, right, or minus 3. So if I write minus 3 here, minus 3 plus 1 is minus 2, and absolute value of minus 2 is indeed 2, right? So that is how we can get a solution, right? Now, more than two solutions, kind of tricky. We'll come back to this later. Let's do no solution first, right? So no solution means, okay, again, let me draw some absolute function and I say that my absolute function this time is kind of like this, right? Now I want no solution, right? So let us say this point for us is 2. So my equation here is absolute x minus 2, and if I say this to be equal to, let us say minus 1, right? As you know, absolute function is always positive. It can never be negative, and so we have no solution. Do you see that? So that is how we can get answers for the three parts. Now, more than two solutions. That's kind of tricky. So we'll have to fabricate something and then figure out the answer. Let me just randomly write down absolute function this time, and then we will see how to get equation which will give us more than two solutions. Okay, so let me write down an equation like x plus 2 plus, let's say, x minus 3 equals to something which I don't know. Okay, let's plot this. So what we will do is we'll try to plot this equation. Now to plot this equation, we'll have to divide our interval from minus 2. So let us say this is our point minus 2 and plus 3. So this is 1, this is 2, this is 1, 2, and say plus 3, okay, in these intervals. Reason being that if you consider on the left side of minus 2, then both of them will be negative, right? So let's solve on the left side of minus 2. It will be negative of these, so that will give us minus x minus 2, right? Plus negative, this is minus x, so let me write minus x, and minus of this will be plus 3, right? That is what we get. So that is minus 2x, and here we get minus 2 plus 3 as plus 1. So that is what we get when we are considering domain from negative infinity to negative 2. Now, if we consider domain between negative 2 to plus 3, in that case, x plus 2 will be positive since it is on the right side of minus 2, but this will be negative, right? So let me use a different ink this time and solve. So we'll use x plus 2 as such. The equation will become x plus 2, and negative of this means minus x and plus 3. That gives us x, and minus x is 0. That gives us 5. So what we can do is, we can write this equation as x plus 2 plus x minus 3 equals to 5. In that case, during this interval from minus 2 to 3, our equation will be true for all real numbers. It will be 5. Do you see that? Equals to 5. So that is how you can get an equation which will have more than one solution. So everything between minus 2 and 3 is indeed our solution, right? So if I do minus 2 here, for example, this will be 0. And if I do minus 3 here, so minus 2 here, then it will be minus 5, right? Minus 5 absolute value will be 5, correct? Including both the points. If I write 3, 3 plus 2 is 5 and 3 minus 3 is 0. So this complete domain between minus 2 and 3 is the solution of this equation. Do you see that part? So that is how we can actually get an equation which can have more than one solution, right? Now, well, you can also see what will be on the right side of 3, or both will be positive. So it will be x plus 2 plus x minus 3. And we are trying to now solve for 5. Is it okay? So we have 2x and minus 1 equals to 5. And that does give us a value of 3, right? So this gives x equals to 3. So that is the solution, correct? So that is how we can actually provide an equation which will give us a solution. You see that? Now it is up to you. You should draw this. I mean, sketch this graph. You can sketch it very easily since we have already done the work. On the left side of minus 2, it is indeed minus 2x plus 1, right? So if I write, so that is the equation. So if I write minus 2 here, I get minus 2 times minus 2s plus 4, and this is 5, right? So it is 5, let's say this is our point 5, and the graph is kind of like this. Now between 2 and 3, we know that the equation is 5, correct? Now after 5, the equation is 2x minus 3. So when I put 3 here, I get 3 times 2, 6, 6 minus 1 is 5. The slope is 2, so the graph will be kind of like this. So this is the function x plus 2 plus x minus 3 equals to 5. And it has multiple solutions. That means between interval minus 2 to 3, all possible values are the solutions for this combination of absolute function. So that is kind of very neat. I hope you appreciate it. Thank you.